In this video, I am going to go over a couple of examples of calculations using the concept of acceleration. Here's our first example. We have a car. It's going to take 30 seconds to go from rest to 20 meters per second. The question is, what is the car's acceleration? So the first thing that's good to do is to remember the definition of acceleration. Acceleration is a change in velocity divided by a time. So we need to identify these things in the problem statement. 30 seconds is our time. From rest tells us our initial velocity, and 20 meters per second tells us our final velocity. Okay. So remember, change in is going to be a final minus an initial. So now we can just plug in our values. Our final is 20 meters per second. Our initial is 0 meters per second from rest, and time is 30 seconds, and 20 divided by 30, if you can't do that one in your head, by all means plug it into a calculator, but comes down to 2/3 or 0.67 meters per second squared. The second example we're going to do is also using acceleration, but instead of finding the acceleration like we did in the last example, we are going to find a time. Okay, so acceleration is a change in velocity divided by time. The key to know that we're looking for time here is how long, right? How long, it's asking about a time. 5 meters per second squared, that's our acceleration. We're told we need to reach 60 meters per second, so that's going to be our final velocity, and we're accelerating from rest, so that's our initial velocity. Now there's a couple things you can do here. You can do algebraic manipulations first, or you can do them second. I think a majority of the students in this class are much happier when they have numbers to work with, so I'm going to do the algebraic manipulation second. What I have is an acceleration of 5 meters per second squared equals a final velocity of 60 meters per second minus an initial velocity of 0 meters per second, all divided by time. So we have 5 meters per second equals 60 meters per second divided by time. Now, in order to get time by itself, I need to do the same thing to both sides. So I'm going to multiply both sides by t. That gets t out of the denominator on the right-hand side of the equation. And the next thing I need to do is divide both sides by 5 meters per second squared. That removes it from multiplying the t on the left-hand side, and I am left with t equals 60 divided by 5. Again, if you can do that in your head, great. If not, pull out your calculator. The answer is 12. And the units, if I look, are meters per second divided by meters per second squared. Now, you may remember your rules for working with fractions. If not, remember the denominator of the denominator is in the numerator. So this second squared actually comes up to the numerator, and this meter is in the denominator, so that gets rid of this. Meters cancels meters, second cancels one of our squares, so the answer is 12 seconds.